Well, now we get to start a new chapter. We've got two sections in this chapter 8, which is going to deal with quadratic functions, parabolas. If you've heard these before, then it'll seem sort of something that you've remembered. These are x squared functions. So we've been dealing with them. We've been factoring them. We've been working with them. In this section, we're going to deal specifically with how these functions graph and how changing the function changes the graph, and looking at those types of properties. Quadratic functions and their graphs. So let's take a look. We're going to work with their graphs, and what we're going to remember is that, well, maybe not remember, but what we're going to find out is all quadratic functions have a U-shaped graph. We've done a few of these, so they either open downward, so a U down, oops, let's see, you can see that, or a U up. So one or the other. We'll see some professionally drawn ones, not just my fingers in the air. But here we go. So what is a quadratic function? A quadratic function has this x squared, and it has a number in front of it. Sometimes it doesn't. I mean, you don't see the number, but when that's not the case, if you have an x squared, there's always that invisible 1. So there is a coefficient in front other than 0. Now, if a were 0, then this would just go away, and we don't have quadratic. We've got a linear function. So I don't know how to erase them. So, but quadratics, ax squared plus bx plus c. Okay, so a, b, and c are constant. Now b and c could be 0. You could just have, a function f of x equals x squared. That's possible. And in this case, a equals 1, b equals 0, c equals 0. And what you're going to find out is as we go through this unit, these coefficients are really all we need to know, because they define the quadratic function. Because there's always an x squared, there's always an x. Again, when it's disappeared, it's because b was 0. But as long as we know these coefficients, we can make the function, the full function. Okay. So one of the things that is characteristic of all quadratic functions is that their graph will have a vertex. It is either the lowest point or the highest point. So it's the bottom of the valley, lowest point, or it's the top of the mountain, highest point. That's just how they look. They will always look that way. Now, some are wider, some are thinner, but we'll see what makes that happen. Okay, so here's a few examples. This one has a low point right here. The vertex is the lowest point. The additional thing is you'll notice the vertex, because the way quadratics are, x squareds, they are symmetrical on both sides. So you cut them in half, the left side and the right side are identical. Identical reflections of each other. So if you think of the axis of symmetry is like a mirror, and on one side the other side is exactly the same. So the axis of symmetry, you'll notice, always goes right through the vertex. So if you know the x coordinate of the vertex, you know the axis of symmetry. The axis of symmetry always has the equation x equals the x coordinate of the vertex. Okay, this one over here, same thing. Now this case, the vertex is a maximum, not a minimum, because it's opening downwards. So we have a maximum. However, our axis of symmetry still goes right through the vertex, and this vertex is going through the vertical line x equals 0. So the axis of symmetry also is x equals 0. Okay. So we tie this together, we get a equation of the axis of symmetry. It's that line that cuts it right through the middle. And here's one last example. We've got a vertex over here. This is going to be a minimum. It's a low point on the graph, the bottom of the valley. The vertex, we're told, is, well, not just told, we can see is the point 2, -1. And so that means that the axis of symmetry is going to be the line x equals 2. Anytime we have x equals a number, that's a vertical line. So the axis of symmetry is x equals 2. Notice the connection between the x-coordinate of the vertex and the axis of symmetry. That is no coincidence. It always happens. It is guaranteed to happen because the vertex is, I guess you could call it the point of symmetry. That's probably, it's not quite accurate because it's really a line of symmetry that it has, but it's certainly the point where you go to the left and you get the same thing as going to the right. Okay. Yeah, you know me, I make up my own stuff as I go. Gets me in trouble sometimes, but you kind of, as long as you make that connection that the vertex is where the axis of symmetry, that, you know, they're together. That x-coordinate is the same. The x-coordinate of the vertex and the x equals that x-coordinate, that's the axis of symmetry. Okay. So let's just take a look at these. We can just, from the graph, when it's nicely drawn like this, we can see the vertex here is the point -2, -1. Okay. Where's the axis of symmetry? You can see what cuts this in half. It's got to go right through here. Sometimes they make it a dashed line. I'll go ahead and do that. Axis of symmetry kind of is this line. It's not really something we draw, but it's going to be x equals -2. It goes right through the x-coordinate. Okay, this one over here, here's a parabola, and I guess we should identify that this is a minimum, right? It's a minimum. This over here, the vertex is going to be a maximum. It's a high point. Okay, so that's the point. So it's 0, 4. What's the axis of symmetry? It's where it gets cut right in half, which is coming right down the y-axis. And I know it's kind of strange to think that the y-axis has the equation x equals 0, but that's how vertical lines are always x equals a number. So the y-axis is x equals 0, and just, you know, for your information for later on, the x-axis has the equation y equals 0. So you'll hopefully get used to that, but it is kind of almost anti-intuitive, whatever that means. Okay, so here they get you 0, -2 is the vertex, axis of symmetry, x equals -2. I forgot it says it's opening upward. Sometimes you just look at it, it looks like it's opening upward, right? Think of it as a satellite dish, and actually very accurate to think of these as a satellite dish because your satellite dish is a parabola. Well, if you don't have one, it's not, but anyone who has a satellite dish, those are parabolic because it's got this really cool feature. Parabolas also have something called a focus. We're not going to get into that math, but it's a mathematical property that if you were to have a beam come from space, it hit here, and they all hit this place called the focus, which can be determined mathematically. That's where you put your receiver, and so you get all these cosmic rays hitting in from outer space and bouncing to that one point. It focuses the rays there. That's why a parabolic microphone works. Sound waves hit that dish and then they go to the microphone, so it amplifies things. Kind of cool, I think. Okay, so yeah, -0, 4, axis of symmetry, x equals 0. That's kind of covered me up, and then it's opening downwards, right? So one way to find the vertex, if we don't have a good graph already drawn, is this little formula. And again, all we have to know is the coefficients. Actually, all we need is a and b. It's minus b over 2a. So once we know what b, we put that there, a goes down there, and that will give us the x-coordinate of the vertex. Then to get the y-coordinate, we plug it back in for x. Or we use our graphing calculator, and there's a feature involved in that. I'm going to show you how to do it with decimals. It's a little easier. And then if you would like, I know not all of you have a graphing calculator, but those that do want to use the TI 83 or 84, I'll show you that feature a little bit later, but I want you to, when I work through some of the homework problems, this time I want you to just kind of get the concepts down. Okay, so we've got this equation. This is our quadratic. Now, to find the x-coordinate of the vertex, we know that it's minus b over 2a. So b is 8, so this is going to be 8 minus over a is 2. So that's going to be minus 8 over 4, which is negative 2. And then if you plug in negative 2, put it in for x, we get, this is 4, 4 times 2, 4 times 2 is 8, 8 times negative 2 is negative 16 minus 3. This gives us a negative 8 and negative 11. So it looks like our vertex, the x-coordinate is negative 2, the y-coordinate is negative 11. Negative 2, negative 11. Another way we could do this is graphing it. Let's go with this Desmos. So desmos.com, graphing calculator, 2x squared plus 8x minus 3. So we could just type it. I'm going to put y equals just because it works. You don't need to have that, but there we go. And then I arrow over, what was it, plus 8, or was it minus 8x? It's plus 8x. Okay. Plus 8x, it was minus 3, right? So this is it. And what I like about this, you can just move it around. Look at that. There's negative 10. That must be negative 11. And then when you click on it, it will give you the vertex, sort of. You click on it harder, and it makes it stay. Negative 2, negative 11. Kind of cool when the math goes together in the graph. You get the visual, and it matches what you get when you plug in the numbers. That's why we're actually able to do a lot of mathematics with the graphing calculators. We do it more visual, and we get a greater understanding. The thing I like about using the graphing calculator, I may have mentioned this before, but it gives us so much more information. Instead of just thinking that negative 2, negative 11 is the vertex like we did here, what else do we know about this? Do we really know it opens up? Well, we might have seen that, well, it's got a positive number, so it should open up. But when we look at the graph itself, clearly we see it does open up. So it gives us more things to look at, more connections to make. We can see this axis of symmetry going through x equals negative 2 right there. See, cutting it in half. We see how the graph looks. We get a lot of information. We have a better idea of what's going on with the graph than just doing what we call the analytical analysis of just using formulas. Both being able to do both is helpful. So I'll click through this stuff because we've already done it, right? Here's our formula. We plug it in, we get our negative 2, take the negative 2, okay, get the y value, right? Plug it all in, we got our negative 11. We did all of this, but so did they. And the writing's a little bit nicer, so it's good to have it there. So you do that, but I want you to also to get used to doing it graphically because it gives you more power and more understanding of what exactly we're looking at. Okay, now they did the graphing too. The thing I like about Desmos is the graphs look so much nicer too. That some of the older technology was kind of, well, I don't want to put any, a lot of you have TI-83s or older ones, and they're black and white. They work, they do the job, but look at how beautiful that is. All in living color. Red, could make the color anything you want. That's what I like about these. You can see, yeah, hold on it. Want to make it blue, you can make it blue. How about purple? Make a royal purple. So Desmos has a lot of features, makes in my book, makes learning more interesting, more fun, and more understandable, especially with all these different colors we can use. Okay, so that's pretty much what this unit's about. Now they want us to find the vertex of this one. Okay, we could do A is 1, there is no B. The axis of symmetry and the vertex. That's actually kind of cool when there is no B. There's no X thing here, right? So that must mean that B equals 0. A equals 1, so we use our formula, minus B over 2A, so that's minus 0 over 2 times 1, which is simply 0. And then to get the y coordinate, we plug in that 0, right, because that's the x coordinate. I'll just put it here. Plug in 0, 0 squared is 0, minus 2a, minus 2 is your y coordinate of your symmetry. So we have 0, negative 2, that's the vertex. Axis of symmetry, well, that's the x coordinate there, x equals 0. And then graph it. Well, again, when we go to decimals, we actually do all of that in one fell swoop, right? We have x squared minus 2. You start to see it. So yeah, here's the vertex at 0, negative 2. We found that. Let's pull it down here. We start to see some other things. We could get x-intercepts this way too, which is kind of cool. We'll talk about those later. We also see that in this case, the vertex is also the y-intercept. Okay, so a lot of things we see graphically, we see it opens upward. But yet to do it by hand, what do you have to do? You got to make a table of values. So they do that. They just plug in all these x values and square it, subtract 2, you get y values. Then you take the x, y values and you plot them all. It'd probably take, 10, 15 minutes to do that. We got the results of the graph just as easily here. Now, one of the things I haven't found out how to do with decimals is to look at a table of values, which I would think it should be able to do it, but I've looked around and I haven't found it. And I feel kind of foolish because someone will probably say, oh, it's right over here. Just do this, little crow. But I have not found it yet, but that's where the graphing calculator, a TI-84, is real nice because it can produce those tables of values. Okay, but again, I want to just get the concept of getting a vertex is getting either the highest or lowest point, in this case, the lowest point, and we saw that on the graph. Okay, we've got our vertex, we've got our axis of symmetry. Okay, here's another one, and we kind of see what's happening now. This is inside the parentheses. It's going to have a different effect on it. So let's just go ahead and graph it. Let's clear that out. We'll put a negative. What was that? X minus 2. The whole thing was squared. Okay. So we see the sort of the negative on the outside does cause it to go open downward. You'll see on one of our lessons, I think the next one even, it talks about how it got sort of moved over. Remember, most vertexes just x squared start at 0, 0, so it got moved over here by 2. But we just click here, that gives us our vertex, 2, 0. Now here, because they gave it in this way, we really don't know what A, B, and C are because it's in factored form. So in this case, we were able to see, though, just by graphing it, that the point negative 2, 0. So the x went over negative 2, y didn't move. So that's our vertex. Axis of symmetry is going to be x equals, remember the x coordinate, x equals negative 2. So we did the vertex, we got the axis of symmetry, and we've already got the graph. Now, I'm going to click through this and we'll see the way they did it is they started putting in values for x, do this, subtract 2 from it, square it, and they got the different values. This allows them to go ahead and graph it. And then from graphing, they could see that this here, 2, 0, is the vertex. But otherwise, analytically, the only other way to get the vertex is you would have to FOIL this out and then figure out what your A, B, and C's are, and then use the formulas, right? But that's where the graphing comes in. It's factored, and we'll just leave it that way. Okay, axis of symmetry. Oh, usually I leave negatives off. I don't usually put them where they don't belong. Good thing I did a double check. It's not -2, it's +2. You guys are probably screaming at me, right? Saying, Little Crow, it's not -2. Where are you getting that -2, Little Crow? And I agree with you. I just, it's +2. But the nice thing about a negative, you can make it positive real easy. Just put an extra line through it. So now it's +2. We'll pretend it never happened, right? So yeah. Very good. Starting to get the hang of it, graph it, find that vertex. Desmos is a great tool. And it does have a lockdown browser, so it can be used for testing. It's got some great things. Okay, here we go, vertex and axis of symmetry. We've got the drill down on this. We've got really two ways to do it. We could use the formula. We could do the graph. This time, let's go ahead and jump to the graph. X squared minus 2x minus 3. So let's come back here. X squared, arrow over, was it minus 3x minus 2x minus 3. There we go. It's at the graph for us. We can just click here on the vertex. The vertex tells us it's at 1, -4, and so we can see this line going right through it here at x equals 1, right? I don't think this thing lets me, it doesn't let me draw on it. I got tools I could draw on it. So what did we come up with? Let's see again. Would it make dark? 1, -4. 1, -4. So we come up with 1, -4 is our vertex. Axis of symmetry, x equals 1, the x coordinate. Okay, so we did that, and we've got the graph. Again, you could have done this. This is a is 1, so you would have got minus, so b is -2, a is 1, so you got a minus and a minus, that makes a plus. 2 divided by 2 is 1, x equals 1, there it is. And then you plug that in for x, so that's 1 squared minus 2 times 1 minus 3. Oops, I don't need that guy. So this is 1, -2, -3. So this is -1 minus 3, -4. Okay, so we can get it in multiple ways. Once we know what the x value is, plug it back into the equation to get the y value, or just graph it and use the tools to get both values. Okay, now again, for them to graph this, they're going to need to make a table of values. We would too if we were doing it by hand, right? So, and it makes it look simple, but what they did is they took -2, plug it in, calculate, they got 5, -1, plug it in, do all the math, get 0. It could take some time. Also, the problem with this is, you see me, it's so easy to make a calculation error to get off by a negative, and then you're adding when you should have subtracted or something like that. It's tedious and time consuming and not as beautiful as the graphing tools we have. Okay, so then we got these, we plot each point, we see what's happening. There we are. Okay, so, but we did this all fairly quickly. So 0, -4, there we see our vertex, and then they draw on the axis of symmetry at x equals 1. And there they are. Okay. So that's the connection we want you to make. And that's going to allow us to keep moving forward with the next few sections we have. Another sort of different question coming out of left field, right? What's a maximum value? Well, just remember a vertex is either a minimum or a maximum. Since this has a negative in front, it's going to open downwards. So we've got a mountain. It's going to have a maximum point. And what is the maximum point? It's the vertex. And specifically, it's the y-coordinate of the vertex. So again, we could plug in, you could find the x-coordinate of the vertex minus b over 2a. So that's going to be a -2. So a negative makes it a +2 over a -1. Okay, so we're back to negative. 2 over 2 is 1. So this is our x-coordinate is -1. Let's plug that in. So then you get, to get the y value, plug in -1 for x minus 2 times -1 plus 3. -1 squared is +1, then you stick the negative on, so you get -1. Negative times a negative is positive, so you get a +3, and then you get a +3. So -1 plus 3 is 2, plus 3 more is 5. So the direct answer to this is the maximum y value is 5. Okay, because the vertex is the point -1, 5. So we can do it that way. Minus x, or we can do it this way. Put a minus here, minus x, minus 2x plus 3, minus 2x plus 3. Not too much, they didn't get too, so we've got that, minus x squared, we got -1 minus 2x plus 3. Oh, what did I do? See, gotta be careful. I took 2 times 1 and I got 3 because I was adding. How many of you do this? This is why I like calculators so much too. 2 times 1, no, this middle one is +2. 1 minus 2, let me cross it out. 1 minus 2 is 1, 1 plus 3 is 4. Okay, and again, some of you are probably saying, wait, Little Crow, 2 times 1 is 2, not 3. And I know that. I just was seeing 2 and 1, and I added them. Okay, it happens. I understand. Okay, so, and again, they just looked at, well, it's going to open downward because the value in front of the x squared, that's negative. So we will get a highest point. They get their A and B, they do this, and they get the -1, which I did correctly. They do this, which I did incorrectly, and they got their 4. So not 5, 4. And then they graphed it. So sometimes just go ahead and start with a graph. See it's 4 there. And then now we look at it, yeah, same thing we've got here. Power of graphing. It shows us so much more, and it takes care of all the details. That's why I use the decimals. It's a little bit straightforward, easier to manipulate, easier to move around when you need to. Yeah, as long as your mouse is working right. So good, excellent. That's all there is to it. So now we've got this one, and this will be our last one for this particular unit. Here's our formula. What is the height of the baseball when it is hit? Okay, the baseball is hit into the air, and its height, h in feet after t seconds, can be calculated by this. So the output is height, the input is t seconds. So before it's hit, or at the instant it's hit, that's really time 0. T seconds after it's been hit. So if you put in 0, you can see it's going to be 2 feet tall. So the ball came in at 2 feet, but then it got hit. And that's where, and for reality, an actual modeling or application for quadratics are projectiles, baseballs, football, things going up in the air, and it's gravity that brings them down. That's what makes the parabola. Okay, so we know it's going up, coming down. All we need to do is find what this parabola is, what the vertex is. That'll allow us to get the maximum height. Okay, so it was hit. It started at, the pitcher threw it in. It's 2 feet tall. We can see that from here. And then let's find the height. So let's go ahead. These are some big numbers. Negative 16. Let's go ahead and use this. So we'll put in minus 16x squared. What was it? Plus 64x plus 2. I think that's what we got, right? Plus 64. Minus 16 plus 64. And you'll see this factor of a negative 16. That is the factor of gravity. That's gravity bringing it down. And notice that's why it's negative. The 64 is sort of the power that the ball has in flying upwards because it's positive, right? So wow, it happens over it. What did have I got everything? It's the x-intercept. Oh, there's the y-intercept. So see, when it starts at time 0, it is 2 feet tall. Okay. Now, how high up does that go? Wow, it goes way up there. So let's maybe come out a little bit. So that ball looks like it went. Now, this is not the path of the ball. It's simply that's how far, because this is the x-coordinate is time. So what we can see is it was back down on the ground after 4 seconds. So the ball was in the air for a little over 4 seconds. What we do get here, though, is the vertex halfway through its game, after 2 seconds, it reached its highest point, which was 66 feet tall. It got to 66 feet. Okay, so the maximum height of the baseball, 66 feet. At 2 seconds. Just like to throw that in there. It was hit at t equals 0, so you plug that in, you get to see, they didn't, now they're going to solve it. Okay, so put in the 0, and you see that at 2 feet. Okay, that's what we did. Also, graphically, it shows up in here as the y-intercept. Okay, so you'll see that that's the height of the ball. The graph opens downward. We know that because the number in front of the x squared, the t squared, is negative. So we've got these values. We could plug those in, get the x value, plug that in, get the y value, which looks like that's what they're going to do. So the x coordinate is 2, but we got that right at 2 seconds by graphing. Then they've got to take that 2 and plug it back in for t. So they're going to do that next. They do that, and they got 66. That's what we got with the graph. So, and as you go on to college algebra, you're going to be using graphical methods for solving more and more. In the last, with the radicals and stuff, I showed you how sometimes you get those extraneous solutions if you do it by symbolically, whereas graphing, you never get the sort of a fake answer. You always get the right answer. So graphing is a very powerful tool. Maximum height is 66 feet. And that's our first section for the night. You guys doing okay? If you need to take a break, remember videos, you can pause them, come back to them. And so maybe I would suggest go ahead and take a look at the homework. Actually, why don't I just stop? I'll do that.